Alright guys, we have some left out things in Kubernetes, small minor things. We'll try to finish those off so that we can move on to those activities. Still can't remember. Alright, that's our regular exercise again. Monolith. You remember this thing by now? That's really good. Microservice. In Kubernetes, we have orchestrator. Self-healing, auto-scaling. Then we have nodes, pods, containers. Then primitives. Primitives. So under primitive, we have HCD, okay. Cube API. Very good. Scheduler. Controller manager. Kubelet and kube proxy. Kubelet, kube proxy. Then we have some more CRI. Excellent. Then we have deployments, service, Ingress, rules, and Ingress Controller. That's how they are different. Yeah, I'm going blank usually here. Alright, so then we talked about namespace, correct. Namespaces, API objects, context, CUN, kubectl, kubectl. All right. That's all? No. Yeah. Then we came to stateful objects or applications. Then we have first tense volumes, first tense volume climbs, storage classes, replica sets, daemon sets. Yeah. Roles, role binding, cluster role binding, config map, very good. Secrets. Help. We stopped here, right? Okay. I'm going to add some more, kind of we missed out, here and there kind of thing. But they are important. One is in services. What is a service? No. Attach an IP to deployment, that's correct. A group of pods is deployment, that's a basic definition. But the purpose of a service is to expose the deployment. Means we actually assign an IP to a group of pods. The very reason why we even talk about services, when you want your application after the deployment, you want the application to be accessible to the end user, the client. Now there are two types of services that we talked about. One is internal, other one is external and in between. What is the internal one? Cluster IP. This is internal. External is load balance. Now, this understanding is really important. So make sure you pay attention. In between, we have one more node port. All these three methods will allow you to expose your deployment to the outside world using some kind of IP. All right. Now let's see. We have our regular master worker stuff, right? So master worker one, worker two. Let's see this scheduler, controller, CRI, kubelet, proxy, kubelet, proxy. All right. Now, if you deploy an application, let's say there are some pods to it. Assume there are some pods to it in a namespace. You deployed it. All right. Now you want to expose these pods to the outside world. All right. Now by default, all the pods are on a different network than the nodes. Let's see what it means. Let's say your nodes are in 192.168.11.x network. So your node 1, assume that it's on 192.168.11. Let's say this is on 10, this is 20, 192.168.11.30. Nodes are on the network, all right? They can communicate with each other, you can ping them, you can do SSH, you can do anything. But the pods are not in the same network. When we set up a Kubernetes cluster, the pods are given a different network, usually that starts with 172. That's the default network. So let's say this is 172.2.1.10. This is each pod has an IP 122.1.20. The pods can talk to each other across the nodes. Means a pod on this node can talk to a pod on this node. How the talking happens? Proxy. That's how they talk. All right? They don't talk direct. They can't, obviously, right? They have to go through a proxy guy. So the kube proxy facilitates talking among the pods. But this is a different network, and this is a different network. And that's purposely how it is kept, because you don't want the pod network or the traffic that is happening in the pod network to be visible to the node network. What happens because of that is, if there are a group of pods as part of deployment, and we want to access these pods, right? Let's say there is an Apache server installed on it in a container inside the pod. What's the default port? 80. This is also 80. Obviously, we want to reach here, right? As a customer, means when an end user, this is where the application is deployed. So we want to reach this IP or this IP. As a group, one of these pods we want to reach. Now, to reach that, we will say we are going to expose it. Let's say this is deployment 1. So you're going to say kubectl expose deployment, this name dep1. All right. Then you're going to say your type, -type, one of these types. If you say cluster IP, what happens here is, don't worry about the syntax, you will get it, all right? And just roughly. So you're exposing a deployment with the name dep1 and you are giving a type. How you want to expose it. Whether you want to use cluster IP to expose it, or you want to use node port to expose it, or you want to use a load balancer to expose it. That's what you say. All right. Now, depending on how you want to expose it, if you say cluster IP, it will allocate an IP from this network, which means another port inside this. The kube proxy will open up another port on your host. That's internal. Don't worry about it. So what we are having here is a cluster IP. You will get again 122.172.2.1. Let's say 50 you got. Now what we are essentially getting is, you are getting a single IP which you can access, and the Kubernetes will redirect it to one of the pods which are represented by this cluster IP. Means instead of not worrying about each pod, you are given a single IP. Now let's say after some time, instead of here, this collapsed and your pod is started on node 1 itself, worker 1. Even then, your service will ensure that these two pods are reachable. So by exposing a deployment using a cluster IP, what you are essentially gaining is you are not really worried about the individual pod IPs, because pods keep getting killed, keep getting coming up. That's what your whole auto scaling process is all about, isn't it? So we don't want to worry about the pod IPs. Or maybe later you may have another node where you're having certain other pods coming up. So if this deployment is growing and shrinking, and if the number of pods are increasing or decreasing, all of them are automatically adjusted under this cluster IP. But the only thing is, this is internal, which means from here or anywhere, if you do a ping to this cluster IP, you won't get any response. It is not in the network. Only these pods will use the cluster IP. Let's see what that means is. Take an example which has multiple containers. So application 1, let's say, is Apache. So you have pods with Apache. And let's talk Tomcat. That makes easy. Tomcat usually serves Java applications, right? Now, usually all Java applications will require a database, right? Now, assume we need a database also, and you decided to use a MySQL database, which means you are deploying another deployment. That deployment also has pods. Those pods have a container MySQL. All right. Now, when a request lands on one of these guys through some mechanism, a Tomcat wants to talk to one of these guys, MySQL. Right? Now, in this case, again, they don't want to talk to individuals. We don't know whether individual IPs will be available or not. So, in this case, what happens is the MySQL will be exposed as a cluster IP. Because who wants to reach MySQL service? Only the internal pods, not from an external one. So when internal services want to reach other services, we usually expose them to the cluster IP. That way, they can talk to each other. So what is happening here is, in a normal Kubernetes cluster, you have Amazon, that one that we are talking, right? So your interface, then you have cart, then you have payment, then you have returns, tracking, all these, right? Now, each one of them is deployed as a, exposed as a service, but only one of them is accessible from outside, which we will see using one of these two. But the rest of the things, they don't need access from outside, which means all these things, cluster, this thing, returns, all these things are exposed as a internal cluster IP type of service. So in a regular Kubernetes cluster, you will see large number of cluster IP type services, which are internal only. Now this is more pronounced or more visible if you are deploying a microservice kind of thing. This is microservice kind of thing. Everything is in a small component, as opposed to the monolith. Monolith, earlier everything used to be a single big war file kind of thing. Right now what they've done is, instead of single big war file, you have 20, 30 war files, each one going inside a container. Each container goes out as a pod as a deployment and as a service. These services are exposed internally to other services using a cluster, right? Now this is internal. Now let's go exactly the opposite. The first one, Tomcat, you want it to be accessible from outside, right? So here, what you do here is, this you will expose as a service, but you will say, I want to access using a load balancer. So the type here you will say load balancer. But the problem with load balancer is, you will say a load balancer, but you have to attach it to an external load balancer. The external load balancer usually comes with AWS or GCP or Azure, one of these two cloud providers. An external load balancer is just like an external IP. You are hitting our jump server, right? That's an external IP. Now, when you hit the jump server, it will take the request and it will forward it to this service that you are exposing. So the load balancer cannot be implemented unless you have an external cloud service provider as some mechanism. So what happens here is, so you have a load balancer first, then you have a service exposed as type load balancer. You're just saying that it's a load balancer. It has to be attached to an external load balancer. Now there are multiple types of external load balancer. You have elastic load balancer from AWS. It's called ALB or CLB, classic load balancer. Then there is a network load balancer, whatever it is, don't worry. Then Google also has Google load balancer. Then Azure has it. There is another load balancer called Metal LB. This is a load balancer that you can install and then direct the request to this service. So if you want to see external requests coming in, you will attach it to a external load balancer. Now this is where your ingress also comes into picture. Pay attention here. When you expose a service as an external load balancer, each service takes up a load balancer. Let's say, just like Tomcat, you also have an interface that also you are exposing to the outside world using a type load balancer. So you will have another service 2, again load balancer. Service 3, load balancer. Now the load balancers are costly, they are. Now if you have 20 things you are exposing, you need to purchase 20 load balancers. Now that's a headache, nobody wants it, right? Forget the cost. 20 URLs, customer does not want to access 20 URLs. They would rather have one URL, give them a page, click on everything. That's what we normally do, right? So the service type load balancer has a problem with each service being exposed to one load balancer. Now this is where we introduce another component in between. So between your load balancer and the service, we are introducing an Ingress controller. Lot of times you tend to think Ingress controller itself is a load balancer. It is not. Instead of having 10 load balancers, what you are trying to achieve is, let me pay for only one load balancer. All right. All my requests will come here. From the load balancer, it will go to the Ingress controller. Now the Ingress controller has set of rules. For example, let's say URL1 is, let's take encodeit.com/abc. That's one URL, /xyz/123. Now, depending on what the URL is, your Ingress controller can redirect the request to one of the services. So behind the Ingress controller, you have service 1, service 2, service 3 like this. And the controller, based on the URL, can redirect it to any service you want. Now, based on the URL, we are saying, right? What we are saying is, if the URL is ending with ABC, send it to service 1. Now, that sentence is your ingress rule. So, when you talk about ingress, there are two things. One is ingress rule and the controller. Now, the controller is the one that implements the rule. Police, law. You understand the correlation? Police is the guy who implements the law. The same way, ingress rule is the actual rule that says if the URL ends with ABC, send it to service 1. That is the ingress rule. Now, who implements the ingress rule? The ingress controller. Alright? Now, the ingress controller receives all its incoming traffic from an external load balancer. So now, instead of having multiple load balancers, you have one load balancer, again one of these three types or 3 or 4 types, that will receive all the requests. It will send it to the controller. The controller will distribute it to the services running on your cluster. That is your load balancer type. So whenever you use load balancer, you still need an external load balancer. Which means every time we do internal testing, we cannot really use this. This is the last stage kind of thing. In between these two, we have an internal part. Node port. Node port is halfway kind of thing. It's not completely internal, which means it's not like inaccessible. The same way, it's not completely external, not like accessible to everybody. In between. So node port, what happens is, if you expose a service using a node port, now again, you give the type equal to node port. It opens up a port on each node of the cluster. So now you will be able to access the Tomcat service on 192.168.11.20, 11.30, 11.10. Usually master will not have any pods. Right? So these two worker nodes will expose a port. Now the port number will be randomly chosen by your Kubernetes cluster. When you say expose, it will choose. Now usually that port number is 30,000 to 32,676. 676 I think, or 767. One of these two, don't worry. So it's about 2,000 ports. Now one of the ports in this range, whatever is available. Same port on all the nodes, remember. Same port, it will pick up some port that is available on all the nodes and it will give it to you. Then what happens is, if you are an internal user, you can simply access it from here. Normally anything that we access is IP:port, right? That's how we access it. So you can access it using this or anything. So node port is usually internal. Now there is a significant difference between node port and load balancer. Node port is L4 load balancer or exposing load. This is L7. No, forget it. Don't worry. It will confuse you a little bit. We'll leave it there. We will add it somewhere else. There are some scenarios where you can use only node port, but don't worry about it. So a service exposed in one of these three. If it is cluster IP, completely accessible internally only, again that's an IP. If it is a load balancer, you need an external load balancer. Between a load balancer and a cluster IP, between a load balancer and a cloud load balancer, you can set up Ingress Control. Now this is optional, remember. This is an optional, and the most popular or the default Ingress controller that comes with Kubernetes is Nginx. There are other Ingress controllers, popular ones, Ambassador. This is another product. All right, Envoy, Traffic, we can set up any one of them depending on how we want it. They're just names. So Ingress controller itself is a product. The popular one is Nginx. Nginx is also a web server we have seen. All right, Nginx has multiple products. So Nginx Ingress controller or Ambassador you can put up, Envoy, Traffic, any one of these things. So we keep exposing things using either node port or cluster IP or load balancer, one of these. This is how things get exposed to outside world. Any questions here? This is important. It keeps coming back to you. Any questions here? You understood the difference among these three? Yes, go ahead. Which one? Internal? Okay. Cluster IP is in the range of network of pods. For example, 172.2.1.10, right? So your cluster IP falls in this range only. As compared to the cluster IP, your node port is on the node network. That's a major difference. Because the network is different for each type of these IPs, only people in that network can access it. Now, what are the things in the cluster IP network? Only pods are there in that network. Nodes are not there in that network, which means nodes cannot access this IP. We are also, as a user, if we are running a kubectl, we cannot access this one because kubectl is running on somewhere outside, and kubectl usually comes to API only. All right, so we don't really have any access to this one. So the reason why cluster IP we use is if other services, other pods want to access another service inside, that's it. Whereas node port is usually when we want to access it or another service available on another worker, means in this network. Now to keep it simple, just remember cluster IP is in pod network. Node port is in node network. Now the moment you know that there are two different networks, only people in that network can talk to it. Very simple. Clear? Perfect. Few? Clear? Any other questions, especially in this area? Very good. Now let's look at some other things here. Labels and annotations. Taints and tolerations. And there are a couple of other words. Horizontal pod autoscaler. Then there is a Minikube. These are some of the words you should know, concepts. Labels, we already know. What's a label? You stick something to something, some object, so it's basically a property and a value. So usually a label is under metadata. I think thing we have seen? Name, let's say my app. So usually a label has a name and a value, a label name and a label value. Now as opposed to these things, now the label usually, the reason why there are two things is labels have certain limitations. The main limitation is it's 68 characters max in length. It also has limitation on it cannot start with a number or a digit. All right. Nothing, no special characters, nothing. Now, because of this limitation, we are not able to put in certain information by using labels, especially in your YAML files. Everything is YAML, right? So, when we are using YAML files, and if we want to put something which is not a common, all right, or a lengthy one, more than 60 characters, especially, let's say you want to put a URL. A big URLs are usually pretty long. Then your label limitation comes into picture. Now to bypass that limitation, they've introduced what are called annotations. Annotation is also a label without these two restrictions. That's it. There's nothing much of a difference, not really from an outside. So the label restrictions are in terms of the number of characters and what it can have, especially special characters, other things a label cannot have. Now those restrictions can be overcome by using an annotation. Now you can ask me why keep labels in that case. Let's keep annotations only. Probably it will happen after the upgrades. Right now they are not really worried about this thing. They are more important bugs they want to fix. So this added annotations, the labels are still there. So sometime when the cleanup or something happens, right now we are in 1.20, right? Maybe by the time we reach 1.50 or 2.50, they'll remove labels. Or they will change the labels and remove annotations. None of these things will happen. So the difference between labels and annotations is in terms of the length that a label can have, in terms of type of characters, and what it can start with, it can have. That's it. And this is more important. Taints and toleration. What's a taint? Taint, general English. Anybody? Taint is a problem kind of thing. What we call dag macha. Correct. Tainted. My reputation got tainted. So basically, something bad happened to a person, right? That kind of thing. To put it simple words, it could be called as a dag kind of thing. Hindi dag, Telugu macha, right? Let's say a taint and a toleration. These two are used in combination. Taints are for nodes, tolerations are for pods. We will try to understand it using an example. Let's say there is a bright light, right? Or instead of light, let's put it something negative we want. Let's say a very strong, pungent smell coming out of a room. Now, who can walk into that room? What kind of person can walk into that room? So the pungent smell, assume that it's a taint, all right? Something is happening over there. Now, anybody who can handle that pungent smell, or anybody who can tolerate that smell can walk into that room. Understood? That's it. That's pretty much it, taint and tolerance. So what we have is, in a Kubernetes cluster, how this gets used is, let's say you have worker nodes, worker 1, worker 2, worker 3. And I assume we allocate taints to these nodes. So you'll say taint, let's say type equal to Windows, I'll say. Here, I'll say taint, again, label I'm using. Type of OS is CentOS. Then taint, type here, Ubuntu, let's say. They have multiple nodes or anything. Now what we say is, if we are deploying an application, and if the pods have a Windows application, what we say is, we allocate a toleration to the pod saying, even if the node has a Windows taint, it can go there. Or let's say, this is master, right? So you will say, this is a pod. Now pod is given a toleration. What we are saying, taint will prevent anybody from coming in, like the smell we are talking. What a taint will does, it taint prevents. So here, if the worker node has a taint Windows, it is preventing all the pods to enter into it or to be scheduled on this. Now, who can be scheduled or what kind of pods can be scheduled? Anybody who can handle that problem or anybody who can tolerate a Windows operating system, or I would say a .NET application. So what we say is, to this pod we give toleration name equal to Windows. You see, these two are same. A taint prevents a pod unless a pod can tolerate it. So you add a taint to the nodes, you add the exact same toleration to a pod. Your example is best way to actually understand it. Taint is a problem. It will try to prevent. When a node is given a taint, node stops the pods. Don't enter me. Then it will allow only those pods which can tolerate that taint. So when we deploy a deployment or when we create a pod, we give it a toleration. We say, if a node has a taint called Windows, you can tolerate it. Then scheduler will look at taints and tolerations. All right, it will try to push it to the corresponding node. So what we are doing essentially here, if you want certain type of pods to go to certain type of nodes, you will use taints and tolerations. All group A applications should go to worker 1, let's say you say, all right, you give it a taint, group A, you give this guy a toleration. All right, just like, there are 100 people and there are 4 rooms. Each room has a color associated with it. RGB, red, blue, red, green and blue. Now anybody who wears a red shirt or a red dress, we can enter into a red room. So the room has a taint called red. A person has a toleration for that red. So you're basically mapping it. So pods will have tolerations, nodes will have taints. Now this is basically to segregate your pods. HPA, horizontal pod autoscaler. The name itself says it, but you'll come across this a lot of times. HPA, horizontal pod autoscaler. If it is horizontal, there is also a vertical. Vertical is not very popular, horizontal is popular. Let's see what it is. Pod is okay, you know. What is horizontal autoscaling? Autoscaling we know. But you increase. That's correct. So something like that. Let's see what exactly it is. We have worker. Alright. Then there is a deployment. Now let's say the CPU on worker 1 is increasing because the load on the pods is increasing. There are more number of requests coming in. When the CPU increases, some cloud providers, what they can do is, they can launch an EC2 instance automatically, scale this deployment, and increase the number of pods. Automatically scale the number of pods. Horizontal is when you increase the number. Vertical is when you increase the size. Let's say this is a 10 GB RAM. If you increase the RAM to 20 GB, it is vertical. But that's not usually possible because RAM increasing happens only after you restart a system. But if you restart, obviously the pod will go off. So you don't want vertical scaling, never. Whereas horizontal is you're just launching another virtual machine and you can simply scale it. So you will auto scale the number of pods. Earlier there are 2 pods, now there will be 3 pods. Now how this is happening based on the CPU. So you can set up a rule in the HPA that says if the CPU is 60% or more, automatically scale it. Now the HPAs will only work with cloud because you are saying automatically the EC2 instance will come up, right? Only a cloud can automatically launch it. If we are doing it on our regular virtual machines or virtual thing, you should have a mechanism to automatically launch it. That's too complicated. So if you have a Kubernetes cluster on the cloud, then you can do a HPA. So horizontal pod autoscaling is CPU based automatic pod creation. Just like more load, increase in EC2 instance, increase the number of replicas. That's it. It all happens automatically. So you can implement HPA only in a cloud. Horizontal pod autoscaler. Vertical pod autoscaler is also there. But if you do a vertical pod autoscaling will happen. Means it will increase the size. But during that increasing the size, the original pods will go down because it has to restart. Hot swappable RAMs are coming up. If you have a hot swappable RAM, it will work. It depends on the hardware. It's like you have a CPU or a laptop. You can put in a RAM and it automatically detects. Like external hard disk you put, it detects it, right? Plug and play. The same way RAM has to be done. But that technology is not really that cheap, so cloud providers do not implement it. And putting anything hardware is they have to walk into a data center. Now, that's too much to ask. So instead what they say is launch a horizontal one. So vertical pod autoscaling is also, as a concept it's there, but Not really useful for practical purposes because our pods will go down when you try to restart your server. The next word you will come across, this is not a concept, this is just a Minikube. In a Kubernetes cluster, we have master and workers, right? Now that's how usually, which means you need to have at least two virtual machines to actually run a realistic cluster. All right, one master, one worker, right? But for practice purposes or for developers, they don't need these two. So what Kubernetes has done is they have come up with a one virtual machine, everything put together into it for practice. Now that is called Minikube. This is a software. It's a Kubernetes cluster, single node Kubernetes cluster.